Hey, do you hear me now? Oh. Yep, I work at Google in Android Toolkit team, so yeah, basically I do it every day, AndroidX libraries. And the first thing that I want to talk, well, AndroidX is just a name, and we can name it support library, Jetpack library, or whatever. We don't really care. What we really want to do is to make a good library, right? So you can name it anyhow, and actually, sometimes good libraries are outside of AndroidX, or even Google. So what is a good library? So there's like, I have some ideas. What, for example, it's pleasant and easy to use. What it means that you don't really guess what this API does. So if you have to like think long enough and you don't really understand what API does, it's not really pleasant because you can easily misuse it and it will result either in crash or you just spend your time and you don't like this, to spend the time on some random API. Other things, reliable and good quality, well, there's obvious meaning it doesn't have much bugs. A bit less obvious meaning it's push you into a good direction. And good direction meaning, well, once you will need to scale a little bit, you won't learn like, wow, this library actually pushed me in a direction that doesn't help me to scale at all. And it pushes you, and you have to throw away this library and do something else completely instead. And so it's kind of a embrace good patterns in your own code base. And it's some libraries don't do this, some libraries do this. Last thing is it's more specific for AndroidX. Let's say maybe not for every library out there. Good for ecosystem because, well, our libraries are very like widespread, so a lot of people use them, and we have to be careful. We cannot take, I don't know, 20 megabytes of rendering engine and put in some core library. That would mean that every app out there would take this 20 megabytes dependency, and that will kill low-end devices or mid-end devices, and it's just like no-go for us. So be very careful about our dependencies. So we have to think about the whole ecosystem when we do a library, but this one is a bit more specific for AndroidX. So how AndroidX help us to do a good library. So I copied this part from our internal page somewhere. And today, well, release planning and distribution, it's very hard and very internal process, not interesting to talk about, or I cannot do really interesting talk about this. But we will talk briefly about tooling that help us to make stable APIs and check that we are doing more or less good things. Testing infrastructure, we have CI, everyone has CI. Our CI is probably worse than yours, to be honest. What is interesting, we have a device lab, so we run tests on real devices. It's important for us because we have a lot of compatibility schemes, meaning that the libraries that hide that on API 15 or 16, this thing works completely differently under the hood. Android API Console, we will talk about this a lot today, and you will learn what is in a second. Docs and development coordination, again, it's way harder than you may think, and I'm not sure how to do interesting talk about that. But there's a lot of code and a lot of complicated stuff. So there are some requirements for you if you want to become AndroidX library. And one of the requirements that will help you probably navigate in business like in this Google universe is AndroidX and everything that has this like package AndroidX star something is AOSP Centric, meaning it doesn't have any Google dependency or strong Google dependency or on Firebase, on cloud, or Google Play or whatever else. So it should work in China, it should work anywhere in the world. Saying this, there is one specific thing. Work Manager, for example, have this module that helps to integrate with GCM. But the core functionality of Work Manager doesn't depend on it. This is fine, because when we have some good integrations with our own services, but the core functionality should be AOSP-centric. The people who know our universe very well may say, well, you kind of lie, because we're aware and there is car library and AndroidX that kind of don't follow this rule. Well, policies change, and we going forward, we hopefully won't have such things. But yes, historically, some things sneaked into our repository. So there is another thing completely not technical, but very hard, and it's probably the hardest problem out of all, is long-term support. Even inside of Google, so there's some team that is not part of Android itself. Let's say S comes to us and say, we have a great idea for a library, helps a lot of people. How we will know that it's not a 1 month or half a year thing for them? Because it's happens frequently. There is one person who is very excited to make a library. They came to us, say like, we want to do this library, but it looks like nobody else in their organization wants to make a library. And what it means for us? It means for us, well, they make an alpha release of a library and will be gone. And after that, we'll have a library that will stay forever in alpha or is completely abandoned. And we don't have a capacity to do that. We don't have even a knowledge of the sphere. Like, for example, ads, well, a core team of Android doesn't have much knowledge about ads and how it should be done and what's our issues there. And the long-term support is actually the only reason why we don't take external contributions as whole features, as a new modules. You are free, and we are happy when someone goes to us and make a contribution to already existing module. But once somebody comes and say like, hey, we need a new feature, again, like how we may know that from outside you won't drop this feature on the floor like in a half a year, or like it's totally fine if you decide to stop being a software engineer, or you moved on and you don't have the time to support a library. But we won't have capacity to support everyone, so long-term support is very hard. And there is thing that it was a plus before. It was kind of like, oh, you get this API review. Actually, it's kind of a requirement after that. If you say, like, we go with AndroidX, you have to follow API review. And so what it is, API review, and what it actually means. So API console. So there is a special group of people, not special, like committee, that try to make all our APIs consistent. And what it means that how we do things in our libraries, pattern-wise, are similar. So idealistically, you wouldn't be able to say that those libraries are done by different people. They would look like they are done by the same person, and because it's shaped very uniformly. However, of course, if you're pay enough attention, you will notice that's not the case, and there's have a lot of different things. So you may actually know quite a lot of, some of the people who works as API console, and we all contribute with their knowledge how to do things better, and I'm part of API console as well. Some of the folks who you may know if you follow Android community, they don't like this, and they say as any process it adds bureaucracy and it takes time before release. So how this process looks like? So if you go, first of all, our code reviewer is open source, so you can actually see how we do things, and you can, if you go, you will see this design from 90s, and sometimes you have this API review mark, and this is a special mark from API console. There's some person where you have regular review, so someone checks implementation detail, and sometimes another person comes and check that your API is proper and has a special mark saying, okay, I approve this change from API perspective. So this person, in this case it was me, looks at this special file. It's Current.txt in API folder. So every module has this Current.txt file that looks like this. It's it just outlines the API surface of every module. So I took a different file. It's not the browser one, but it's just shorter and looks better on the slide. So what it strips away all details. It leaves only public surface that is usable for clients. And we look on the changes in this public surface. So you see all public classes, all public methods, all public annotations that related to the method. So we look at this file, we see if it changed good or not, and then that's not the end. After this, there is a post-commit review. So your commit landed, there is our group of people, not our group, it's the same group of people, but it's a special meeting. We go for every change and see if, not every change that touch API surface, and reread this and send some additional comments as a bug, asking people to change things if you think it's not good enough. Because it's a bit better just because the person who review the CL, first of all, is just one person, and it's a group of people. The second thing, you kind of, if you review the same thing over and over again, you get used to this, and fresh new look always helps, and we really care about API services, so we have this thing. But it adds the time. And what's the things that we look at? So, like, what kind of patterns? So, to warm up, I will talk about super simple thing, nullability. If you've paid too much attention to the previous slide, you may notice that the bundle has a question mark next to it. That means it's nullable. So it's kind of a mix of, it looks like a Java thing, but has this nullability in Kotlin style. So yes, not first thing, but one of the things that we looked at manually for quite some time is that your API has proper null or non-null annotations. So yes, it was all about, once we decided and said like Kotlin is approved as a first-party language on Android, it means that we have to make it Kotlin friendly, and from API perspective, it means that Java and Kotlin has a bit different perspective on nullability. Java says like, we don't care, there's no explicit contract about nullability in API surface. However, like as a user, you always have some assumptions. For example, if there is a collection.iterator, you always have assumption that it never returns you null, and if it will ever return null, like the whole world will be screwed. And then Kotlin has very explicit. It says like, okay, if it's have a question mark, it's null. If it's not, if it doesn't have a question mark, it's not null always. So it's very good to have this explicit contract. And so this is the first thing. And the painful thing, we didn't have a proper tooling for quite some time. So we looked at that every API properly marked as non-null or manually. So we actually check, okay, does this function have a everywhere proper annotation or not? It's very, very, very boring. However, compatibility changes about that your function cannot decide, well, it always return non-null, and now in the next release it will return null. This will break all existing clients. That thing is not compatible change, and that thing was verified properly in the tooling right away. But the rest of the thing we have to do manually, but now we have a proper tooling. The one interesting thing, time doesn't stop, and so you have to re-evaluate your guidelines. So very, very fresh thing, Android Studio 4.0 allows you, so previously what you were able to do is you can use Java 8 language, which means that you can use lambdas, you can use some of this nice catch syntax, but you weren't able to use objects from Java standard library, for example, in classes, so optional wasn't available for you. Now in 4.0, R8 supports like this desugaring the GDK itself, so it compiles these classes right into your application. So optional become a thing. Optional, if you don't know what it is, it's called maybe in other languages, but basically it says like you get a result, you get a thing, but it maybe you have it, maybe you're not, you have to check. So it's basically the same thing as nullability annotations and Kotlin nullability. And for us, from a API perspective, we have a question, well, should we allow this or not? Because it's kind of have the same meaning, and we thought about this. Well, looks like there is no reason to allow this. So we say, okay, never use this in the public surface because we already have our mechanism, Kotlin nullability, and this non-null and nullable annotations that does the same things. But Kotlin have a better thing just because Kotlin know about nullability in very low level. It knows in the compiler level. So it has this smart cast. If you checked already for non-null later, you don't have to recheck it and so on. So it has nicer syntax and it's more compact and fluent. So we thought, well, it doesn't make sense. So we have to adopt our guidelines, say like, hey, please don't use optional. It's not a good thing in our thing. So our thing to look at, for example, there's like lots of things. I won't be able to talk about all of them today. There is singletons. So the short version of our reaction on singleton in the room is we don't like them a lot. And like there's in a room with like no one is like it doesn't go outside, but in the room is quite a lot of anger when we see Singleton in the library. And to be honest, I wasn't sure that I should talk about that because that will be like quite obvious, and I think like a lot of people heard about that, and there is nothing new that we will hear here. But for some reason, like every other, like I don't know, half a year or something, someone comes to us and say like, yeah, we know all of that, but in our case, it makes sense. And usually their case isn't special. And the only special case that is there is Work Manager is already implemented, so it's not them. So why we don't like it so much? So there is like lots of issues with singletons, and like there is configuration conflict, testability, and startup time. So let's look at a configuration conflict. I took like, let's say in a singleton you have this function to enable some kind of a mode, or our frequent examples would be you need to pass some executor on it, or you need some initial init method. And what it actually means that if you have two different libraries, or your library and your app itself, and they want to enable different things on it, they start the conflict right away. The thing that we want to enable may be incompatible, and after that the client and your library, or like two libraries, should somehow coordinate what we want to enable. And I saw like multiple versions of how people suggested to do this, and usually it's very complicated, and you never want your users to do anything of this. So there is the one thing that immediately falls apart. Our thing is startup time. Yesterday there was a very nice talk by Reno, if I didn't mispronounce the name, about startup time in Android applications. And there was quite a lot of things that say like, hey, we want to initialize the things later. And singletons usually don't provide this capability. We have just this, so you instantiate your instance right away when class is loaded, so it's not even lazily created, and that means it's very hard to control, because you can control when class is loaded, but it's very, very brittle, it's very hard to enforce, and any person who have a job to enforce that your singleton is initialized not too early have a very, very bad time. It's maybe a bit our Google specific, but in Google there's like a lot of libraries, and they care about this thing, and every big app cares about that a lot. That's fine. Yep. You can say, well, we will create our singleton lazily. It will help a little bit, but it's still very hard to control when you want to create it, and you kind of get this control out of user hands. So there's testability. So after that, there's testability is, I think, one of the most famous issues. Well, your state is preserved on test invocation because you put your state in a static thing, and the static thing lives across, because nobody restarts GVM, lives across the test invocations. And after that, you have to come up with some kind of a strange API, how we will make this singleton to work in tests. Whereas like create for test function in public API, which is very bad, because what will happen if user decide to call it anyway in their production app or something like that, because they really wanted to restart it, and how the things will fall apart. Or the smarter folks say like, we'll create a special rule and create special module, so it's like it adds up like discoverability problems and so on, because we have a separate artifact with testing, and that allows you to test with singleton, but that's still not very nice, because you have to know this artifact exists, you have to be able to locate it, and so on. And the last thing that people say, well, they can mock our singleton, and API console back to this state. We don't like this suggestion a lot, and we will talk about this now. So testability, and so generally in libraries, when you have to think about this question, which is like not how you test your library itself, but how users who use your library test their app and test this special part, because it's a bit different story, and you have to think about that. And with mocks, there's like some problems, and the testing strategy for like saying, well, they just use mocks, have the following issues. So I took very simplified example. No one will probably mock a bundle in their right mind, but if you will substitute bundle with fragment or fragment manager, believe me, things won't become easier, and you will fall apart in a more complicated way, because their behavior way more complicated and smarter than just a bundle. So what you do, you just do the regular thing. You get a string, you say like, okay, on a get string with this key, return some other string. Just it. And the key thing, you don't do this. You just don't, no one tests the mock itself because it doesn't make sense, because you just created a one line above. There is no sense to do this. What you do instead, and it's the main part, what you do instead, you pass this thing into some component. It can be library component, maybe your own app component, and this app will pass this mock to something else. And after that, you test state of some either this component or some other component, that this state is now in a state that you expected. So you would want to test this. So how it actually falls apart. So the main thing is, in a version like in the first version, when you write tests with mocks, everything always works. So everything is fine in the beginning. It's it's a main trick. Everything is fine. Your library component just do this, and you properly mocked the bundle. No problems at all. And it's a library thing, so you don't really control this code. It's a code that lives in AndroidX or whatever else, like Guava. So after that, library version 1.1, it started to do some legit changes. So it started to, okay, we want to check if the bundle contains this key before getting it. For some reason, they say it will be faster or whatever. And this is a problem with your mock, because your mock didn't expect this call. You broke the contract of bundle, because the natural contract of bundle is if you're having something by this key, you should return true on contains as well. You didn't this API guarantee was broken. Library, of course, didn't have any clue that it can be a thing or it should be a thing. So and then your test will be broken. So recap of the situation: test worked. You bumped the library version, and your test is failing now. And it's not some puristic or not real life case. It's in Google Free, we have this kind of things every day. Google Free is internal Google repository of where all apps lives. And when we update AndroidX library there, some mocks every other day is broken. And with just similar use case, but in a bit more complicated state, and it's just harder to debug. But the whole idea is totally similar. So what you should do as a library owner? Oh, I forgot about service. So why users do this? So okay, you can always blame clients and say well, they do this wrongly. But truth is, sometimes they do this not because they really wanted to do this. It's just because we don't have any other way to do it. And you, as a library owner, forced them to create. You didn't give them a chance to create this object, and we have to force them to create a mock because we cannot do anything instead. It's either too hard to create a proper thing, or it's completely impossible to create a proper thing. So, you, as a library owner, should do the first thing. You have to be sure that for this alternative to mocking exists, because if you don't create it, it means you kind of don't give a choice to user. So it's fairly bad. And how to actually notice this is, it sounds very it's not very smart advice, but somehow we ourselves miss this from time to time. It's a write a client app that actually use your library, and you test this client app. It's maybe a very small app, but it still does emulates what you expect from clients. And you try to test this app, not your own library, and you will see how it's easy and there is no problems, or sometimes there is a problem and you'll notice this and you'll think okay, what is my suggestion to a client? And there is a second thing. Well, sometimes in the bigger orgs you have this client owner is like infrastructure team that is responsible to update all libraries and keep them in managed state. And the advice for those people is be strict. And what we, not me, but like whereas folks in Google Free did, we banned from mocking certain types. For example, fragments and activities, they are completely banned from mocking. You cannot mock them in inside of Google Free. So just because otherwise we wouldn't be able to update Android there at all. Never. This is because the test will always falls apart. So our advice, so sometimes you don't have a control and you don't have a choice, so you have to create something like a mock. So what you can do is create your own fake and make it centralized and test it. So once the library is updated, yes, you may have like this fake will behave a bit differently than the library, but it will be centralized. You won't fix the same thing in the different tests. You'll fix it in one place, and that will be beneficial for whole organization. Actually, it's kind of a Epilogue. So Epilogue is just this. It's centralized fakes that you can use in your Android apps. So you don't. So no one recreates the fake for a fragment and so on. Yeah. So next thing is a bit of binary compatibility. So there's the one thing, like when you update the library, you may didn't provide this good testing story. So, and after that, you're kind of have a problems with updates. So our thing is binary compatibility helps you to make this process of updates is easier. I copied the official definition from Java language specification. It's just hard to understand, I would say, but it's, well, not hard, it's like written very nicely. But what it means that you take your app, you bump one dependency, you don't recompile the thing, and everything works. So something that maybe not very obvious, or like it was confusing, at least for me, in the like bits when I haven't done this as my full-time job, is, well, why do I care? Because I always recompile my own app. Well, you care about this because, yes, you recompile your own app, but the libraries that you depend on, they are not recompiled. So if they depend on one version and your next update is incompatible with it, it means that, well, you have a problem in your library will fail. Not your library, but the library that you use will fail with new version. So what are the changes that like breaks compatibility? Some obvious one is like you decided to remove method, right? And if if not your, but some code used that method, it doesn't exist anymore. It tries to call it. You have a failure. Fairly obvious one, and it's easy to track. Adding a parameter is our one. Well, yes, old code won't pass a new parameter. Small, like additional thing in Kotlin, for example, you would say, well, I can add a parameter with default value, but by default, if you don't do anything special, it's still from JVM perspective, it looks like a method with new parameters, and your old code will still fail, even though you provided the default parameter. And what you actually, if you're interested in to do this in Kotlin, you would have to, there is like special notation JVM overloads that would help you to avoid that. So if you're interested in this topic, there's great guide on eclipse.org with all possible cases that like will describe any possible situation in life, and it will tell you if this situation in your life is compatible with your previous life. So there's one thing that I wanted to tell you is there are allowed breaking changes, even though it sounds like scary, but it's kind of a reality. So in this example from my life, so a long time ago, a couple of years ago, so we decided to add this getLifeCycle method in every fragment out there. And in Glide, if you know this library, which like helps you with image loading, we already have a lifecycle method in their fragments. It was internal fragment, but still fragment. And this results in a clash just because, yes, there is a same method but with different return types, and JVM doesn't allow this. And then this is incompatible change. So what happened then? We went and renamed the method in glide, and still added this method in lifecycle. So get lifecycle. The reality is, as this guide in eclipse.org says, probability of that is very, very low, so it's frequently considered as a safe change. And if we say we don't want to allow this, it means that we cannot add new APIs in fragments, we cannot add new APIs in activities, we cannot add APIs in any classes that we ask you to extend. We don't like, so previously, yeah, we asked you to extend things here and there. Now we try to avoid that, but historically we had those, like a lot of APIs that were extension based, and we either say we're not going to evolve those APIs, or we have to say, well, we allow those kind of changes, and we decided to say that's fine. So this is our thing. So quick thing about like what we do about binary compatibility. There is like semantic versioning. Semantic versioning meaning. Do I need to explain semantic versioning? Oh, I don't know. Okay, I'll tell what semantic versioning is. So semantic versioning is it has a special meaning for every update. So if you have a free number, where is the version can be like 1.2.3. So number 1 is a major version. Changes in major versions can be breaking. So this bump is very, very troublesome for users, and we really try to avoid this kind of changes, or avoid this kind of changes without some kind of a tooling that will help you to migrate to a new thing. For example, this kind of a change was migration to AndroidX, right? So that thing, migration to AndroidX, we change all packages, we reshuffle some classes where we live in some artifacts, and without tooling, that would be impossible change. So like no one will be, like just a few people would be able to migrate to the new world, and migration would be very, very hard. So we decided, okay, we really want to make this change, and it was very, like, it wasn't really an easy decision, but we wanted to do this. So we provided tooling alongside that helps you to do this major version change. So after that, so it was first my major version, there's minor version, meaning this incremental changes. They must be binary compatible. It's just like when you add new API, you do this new minor version release. And the last thing is the patch set version. In AndroidX, it will happen only when you have some major bug. So you have some major bug and you really want to push this hotfix somewhere, you would create a patch set version. Lately, we don't have much patch set versions, and all of the releases stopped on .o, and when we have a new minor version release. So last thing is Metalava. Metalava is our tool to create those Current.txt files. So it's written by our Tor Norba, if you know him. He's like lead of the studio. So it generates this Current.txt. Unfortunately, so if you're really interested in this thing, you can use this. It's open source as well as almost everything what we do. But it has some documentation, but it doesn't have much documentation. So it will be a bit of struggle to use it at first, but it's still a great tool if you need, or if you handle inside of your organization some library or outside and you want to track that. I would advise you to take a look and probably use it. And if you wrote some kind of a lint checks yourself, that would be a bit easier to understand what's going on there. And last thing is AndroidX Gradle plugin that helps us to integrate Metalava in our build. Again, we have vision or something like that, which is like not going to happen soon. But one day we will try to productionize this in terms of like you would be able to take this part of Gradle plugin that integrates Metalava and just drop into your own project. You will get this API versioning right away. But unfortunately, it's not a thing today, and we'd like to do this one day, but we don't have enough capacity to do it right now. So, but if you're really interested and you have some motivation to do that, again, our code is open source. You go to builders.rc folder and read it for a while, and then you will see that it's fairly trivial to take this out and copy paste, which is quite horrible, but at least you get our tooling that help us to track things. And yes, in Google, actually, some internal teams, more or less, we have a different build system. We have used Bazel, but we use Metalava just because we really want to track their API stability as well. So what else? Yeah, about like so it was like quick overview of the things that we try to do when we build the library and try to build a good library. So, and we approach this from all possible angles. We approach it from an angle like, let's create additional process that will make sure that library is good. So we check the patterns that you use, the APIs that you expose, and so on. So you don't create something weird. And just like, we don't think like people are evil or something, but it turns out doing the libraries is a bit of a special art or special like area of engineering. And if you're a Bluetooth or media expert, you may still not do great library just because it's not your field, and it's actually fine. And we kind of help you to do this with our custom process of review and helping you saying like, well, you will have some problems going forward doing this. We create this custom tooling with Metalava and these AndroidX plugins that help us to ensure that things stay stable. And we spread this culture of patterns. We like talk about them. We like create some lint checks and so on. And after that, we still have some mistakes. So it's not like one bulletproof process. We still try to iterate on the things. Yes, but it just shows that like, doing libraries is a very complex thing, and even though we can try to do it from all possible angles, there is no like 100% sure result thing. So if you have some issues with AndroidX libraries, please file the bugs. Don't. Of course, if you have a good file report, bug report, it helps us. We will be able to iterate on it quicker. If you don't really understand anything, you can actually reach out a lot of people on Twitter. We are not that famous, so you will be able to ping them, and we have a chance to answer you and say like, well, we did this for that reason or something like that. So please reach out. We try to be open as much as possible. However, like even for Google, always looks like a huge corporation that have an endless amount of resources. When you go down to the exact team level, like our team level, it turns out like capacity is a thing, and like we cannot do everything what we want to do, which is weird. Probably have some strange resource scheduling thing in Google, but it's a thing. So yeah, I think that is it for today. And this is like everything I had.